Algebra 2, Concept 33 Notes. This is Part 2. We're looking at right triangle trigonometry. So let's continue in the notes now with example 4. We're asked, it says use the trig ratios to solve the missing lengths. So we want to find the lengths A and C, round to the nearest tenth if we need to. So what I notice also is the angle of 28 degrees. Now we only know one side length, so we can't use the Pythagorean theorem. But let's look at what we know and what we want to know. So we know the angle here, that's 28 degrees. We know the side length that is touching it, but not the hypotenuse. So this is the adjacent length. What we want to know is the opposite, and we want to know the hypotenuse. So we're just going to think of trig functions that have what we know and what we want to know. So we know an angle. So we think what trig function involves the adjacent, that's what we know, and the hypotenuse, what we want to know. Well, that would be cosine. So we could set up an equation, and we could say the cosine of, this time we know the angle, so we're going to put the angle in there, 28 degrees equals 15, because that's the adjacent length, over C. Now we're going to solve this just like we would any other equation. So we're going to multiply both sides by C. So we have C times the cosine of 28 degrees equals 15. Now you're going to have to get your calculator on this, and you need to locate your cosine button. You also need to make sure that the mode of your calculator is in degrees. So if you don't know how to check that or how to change it, you need to raise your hand to get help. Okay, so now that your calculator is in degrees, let's finish this problem. So we want to get C by itself. So we're going to divide both sides by the cosine of 28 degrees. We don't know what that number is, but in a minute we're going to let our calculator figure that for us. So now what we have is C equals 15 divided by the cosine of 28 degrees. So now here's the part where you let the calculator do this work for you. You simply say 15 on your calculator, divide by, press your cosine button, type in 28, and you should be in degree mode. Close those parentheses and press enter. So you should see 16.98. So if we round to the nearest tenth, that would be up 0, so 17.0. Now we've got two options to find the length of A. We could use the Pythagorean theorem now that we know two lengths, or we could use another trig function. So let's use a trig function. So I want to know the side that's opposite, and I was given the side that's adjacent. So I think, well, what trig function uses opposite and adjacent? Well, tangent does. So I'm going to set up an equation that says tangent of 28 equals opposite, which is A, over adjacent, which is 15. So now I'm going to multiply both sides by 15. So A is going to equal, this time we'll take 15 times the tangent of 28 degrees. So on your calculator right now, type 15 times tangent of 28, which will round to 8.0. Now let's look at the second example 4. So we're going to solve triangle ABC. And it says in triangles, capital letters are used to denote the angles. Lowercase letters are used to mark the side lengths. So side little a is opposite from angle big A. Side little b is opposite from angle big B, etc. So we're going to solve right triangle ABC using the given measurements And what we're going to do is, rather than find all the angles, I think your notes page just says find the side lengths. And we're just going to have the information given that angle C is our 90-degree angle. So first, let's draw a picture of this triangle. So there's our 90-degree angle, and that's C. We don't know what A is, but we know that angle B is 45. And we know that side C, so side C will be across from angle C, is 5. So then what we're trying to find are sides A, and we'll denote them with little lowercase a and B. Now I'm going to note that if one of my acute angles is 45, then the other one has to be as well. So this is a 45, 45, 90 triangle. So what that means is that our side lengths are going to be in the ratio of 1, 1, square root of 2. So we could set up a ratio or proportion. From the first triangle, we could say side B compared to side hypotenuse 5 is equal to, and then I'm going to use the corresponding lengths, 1 over the square root of 2. Then I'll simply solve for B. Square root of 2 times B equals 5. So B equals 5 divided by the square root of 2. Or if I rationalize that, 5 times the square root of 2 over 2. And then I know in a 45, 45, 90 degree triangle that the side lengths, the legs, are the same because the angle measures are the same. So I don't have to do any more figuring. Now in B, let's draw a picture of this triangle. So we've got 32 degrees. Angle B, we're not sure. And then side B, which is across from angle B, is 10. So we're looking for side A, which is across from angle A, and side C, which is across from side C. And I'm going to write down what we're missing. So we're missing angle B, we're missing side A, and we are missing side C. So to find angle B, I can simply subtract from 180. So I'm going to subtract off 90 and 32, and I'll get that my angle B is 58 degrees, because the angles in a triangle, you know, have to add up to 180 degrees. Now side A, I'm going to use a trig function, so I've got 32 degrees. I see that A is opposite of 32 and 10 is adjacent. So opposite and adjacent use the tangent. So the tangent of 32 equals opposite, which is A, over adjacent, which is 10. So I'm going to take on my calculator 10 times the tangent of 32, close your parentheses, so 6.24, so that'll round to 6.2. Now to find side C, let's use another trig ratio. So we know that 10 compared to 32, the angle of 32 degrees is adjacent. So we've got adjacent, and side C is the hypotenuse. So the trig function that is adjacent and the hypotenuse is the cosine. So the cosine of 32 equals 10 over C. Now to solve that, I have to multiply both sides by C. So what I'll end up doing is taking 10 and dividing it by the cosine of 32, which will give me 11.8. So now I can transfer these lengths up here, and I know that I have found everything that I need to. All right, now here's a problem using a really cool concept, an angle of elevation. So when we did the definitions, you saw that an angle of elevation is formed with the horizontal line looking up from it. So we've got a problem where a parasailer is attached to a boat with a rope of 72 feet long. The angle of elevation from the boat to the parasailer is 28 degrees. Estimate the parasailer's height above the boat. I always draw pictures for these. My pictures are awful, but we've got there. So here is the person, not to scale, and then right here is our horizontal line. So the angle of elevation up from that is 28 degrees. The rope is 72. And so estimate the height above the boat, which is this, and we'll call that X. So if I look at my triangle, I look at what I know, what I want to know. I know this angle, I know this, or I want to know the side that's opposite, and I know the hypotenuse. So I think what trig function uses opposite and hypotenuse, and that would be sine. So the sine of 28 degrees is some height, we're not sure, over 72. So we'll multiply both sides by 72, and then on your calculator, take 72 times the sine of 28 degrees, which is 33.80, so we'll go 33.8 feet. So about 34 feet in the air. In this problem, a nursery plants a new tree and attaches a guy wire to help support the tree while the roots take hold. An 8-foot wire is attached to the tree and to a stake in the ground. From the stake in the ground, the angle of elevation of the connection with the tree is 42 degrees. So to the nearest tenth of a foot, the height of the connection point, find the height of the connection point on the tree. So the triangle is drawn for you, so you look at what you know and what you want to know. You know the angle 42 degrees. You want to know the side that's opposite, and you know the side, the hypotenuse. So you think opposite and hypotenuse, which is sine. So you can write an equation. The sine of 42 degrees equals opposite, which is some length x, over 8. Multiply both sides by 8. So on your calculator, you will take 8 times the sine of 42 degrees, which is 5.35 or 5.4 feet. So that's how high the connection point is on the tree. Now pause the video and do the independent practice problems, and then come back to the video to check your answers. Okay, let's check these independent practice problems. So to find the 6 trig ratios, you should have found that the third side is 8, and then you should have sine of theta is 15/17, cosine of theta is 8/17, and the tangent of theta is 15/8. And then the cosecant, secant, and cotangent of theta are just the reciprocal of those. In number 2, you should have found that the third side, which is the second leg, is the square root of 51. We're going to leave it in exact values. So the sine of theta is the square root of 51/10, the cosine of theta is 7/10, and the tangent of theta is the square root of 51/7. I don't know if I said the cosine right, 7/10. And then the cosecant, secant, and cotangent are the reciprocals of those. So make sure you pause the video so you can look at these answers to make sure that you can check your work. Here are the answers for numbers 3 and 4. So on number 3, the triangle is a special right triangle, 45, 45, 90. So I drew one of those and I used it to set up a proportion. So I said x over 6 equals 1 over the square root of 2. And then when you simplify, you'll get 3 times the square root of 2. We do not want to estimate on our calculator. We just leave it in exact terms. On number 4, when we find those two side lengths, you'll get that A is 11.5 and B is 3.5, rounded to tenths place. So this concludes part 2 of the Concept 33 notes. Make sure that you go now and you do a teacher talk and get all your questions answered and go through each of those problems with the teacher for the teacher talk so that you're certain to understand Concept 33 very well before you start the practice problems.